Good evening, my dear students. Today's topic is carbonyl compounds, lecture second. In lecture seconds, we will study about the remaining chemical reactions of carbonyl compounds and some Cannizzaro reactions and some other name reactions. So I start and continue with the addition of ammonia and its derivatives. So this reaction is again known as addition elimination reaction. This is known as addition elimination reaction. This is a very important part. Now I write the general reaction. What is the general reaction of this molecule? Suppose I take one carbonyl compound, that is C double bond O. On reaction with ammonia or ammonia derivatives, so I replace one hydrogen with the Z. In presence of dilute acid, pH range is approx 4 to 6. The final product is C double bond N Z, and one water molecule is removed during the reaction. So general reaction is carbonyl compounds on reaction with ammonia derivatives. This water molecule is removed and C double bond N Z is the final product. Now I take one by one examples. First, mechanism. So in the first step, acid react, HCl react with carbonyl, and carbonyl compound converted into carbocation like this. Now the ammonia derivative take with the carbocation very easily. And it is converted into like addition product. Nucleophile at the carbon, that is the nucleophile, and H at the oxygen atom. This was the theme. Now after removal of H+, NHZ and OH is the final product. In the next step, this hydrogen is again removed with this OH group in acidic medium, because OH is converted into good living group, and finally C double bond and Z is the final product. This is the final product. The first step of the nucleophilic addition is known as RDS step. So I repeat the mechanism. In the first step, carbonyl compound gain the proton from the acid, convert into carbocation. Now the weak nucleophile ammonia or ammonia derivatives take on the positively charged carbon, and addition product is formed. But this product is not stable. That's why first hydrogen is removed, then neutral molecule is formed. But again, after removal of one H and OH group, that is ultimately water, and converted into C double bond N compounds. So overall, in this reaction, addition and elimination both takes place. So this step was for addition reaction, and this step was for elimination reaction. So overall it is known as addition elimination reaction. Now if I replace the Z with different groups, then different functional groups are produced. For example, suppose I take preparation of oxime. So reagent is hydroxylamine, NH2OH. Oxime means C double bond N OH. For example, I take RCHO, NH2OH in presence of dilute HCl. Then finally RCH and OH is obtained. This is a stereo center. If two different groups are present on the carbon atom and lone pair and OH is on the nitrogen atom, then products are two products are formed. These are geometrical isomers of each other. Suppose I take the second preparation of hydrazone. Hydrazone means C double bond and NH2 group. This is the hydrazone. So reagent is hydrazine, NH2 dilute HCl, and this is also written as NH2 NH3 Cl minus. You can write this. Now, suppose I take an example of ketone on reaction with hydrazine. So water is removed. So final product is hydrazone. Now next one is preparation of semicarbazone. Semicarbazone is C double bond and NHCO NH2. Reagent is NH2 NHCO NH2. It is known as semicarbazide. In semicarbazide, there are two NH2 groups, but this lone pair is localized, that is more nucleophilic. This lone pair is delocalized. So we can take any example. Suppose I take this example with semicarbazide in presence of dilute HCl. Finally, semicarbazone is produced. So this nitrogen acts as a nucleophile in this reaction because this is a localized lone pair. So there are three examples. First is oxime prepared by hydroxylamine. It is known as hydroxylamine. You should learn the reagents. Second, preparation of hydrazone. So reagent is hydrazine. On using hydrazine, hydrazone is formed. Next is preparation of semicarbazone. Structure is like this. So semicarbazide is used. In semicarbazide, there are two NH2 group. It was asked in many exams. So why this nitrogen is react in this reaction? Why this cannot? So reason behind this is lone pair of this nitrogen is delocalized. That's why it is less nucleophilic. And the first NH2 is more nucleophilic. The next addition is 2,4-dinitrophenylhydrazine. That is the lab test of aldehyde in ketones also. preparation of 2,4-dinitrophenyl hydrazone. This is a yellow-orange precipitate. Reagent is 2,4-D and P. Reaction is like this. This is the phenyl group. Numbering is like this. So you can say 2,4-dinitrophenyl hydrazine. So after the complete reaction, water is eliminated and yellow-orange precipitate is obtained. This is generally used as a lab test of carbonyl compounds. So this is yellow-orange precipitate of hydrazone. Next, preparation of amines. Preparation of amines. So ammonia is used. So RCHNH is the final product. This is less stable product. Now the next is reaction of carbonyl with different amines. First, with 1 degree amine. So on reaction of carbonyl compound with 1 degree amine, water is eliminated and this is alkyl amine. This is known as alkyl amine. It is also known as Schiff base. If the primary amine is taken, then the product form is weaker base. Nitrogen is sp2 hybrid and lone pair is localized. So because of sp2, it is less basic and product is known as alkyl amine or as well as Schiff base. In second case, suppose I take with 2 degree amines. So in 2 degree amines, suppose I take the compound like this, cyclohexanone with 2 degree amines. Then nucleophilic addition take place. Nucleophile at the carbon atom and hydrogen at the oxygen atom. So in this case, water can be removed between carbon and carbon only, not from the carbon and nitrogen. So in this case, product is little different and it is known as ene plus amine. So ene plus amine is overall known as enamine. So in 1 degree amine, product is alkyl amine, that is Schiff base. In case of 2 degree amine, overall water cannot be removed from the nitrogen atom. That's why the one hydrogen is taken removal from the carbon and final product is known as enamine. But in case of 3-degree amine, there is a unstable product with 3-degree amines. R3N. So product is unstable. So reaction goes backward. So there is no stable product is obtained with 3-degree amines, or you can say no reaction. So these are the addition reactions of ammonia derivatives with carbonyl compounds. Now come to some examples. Suppose I take the example number 1. With axis of NH2H. So there are 2 aldehyde groups are there. So dioxime is obtained. But in the same question, if I take the hydrazine, then both nitrogen react simultaneously with this. 2 water molecules are removed. So this is a cyclic compound, cyclic and aromatic. Both lone pairs are localized, and this is a cyclic product. So the second question, suppose I take the similar type of question. If this is ketone and I take the aldehyde like this, or right here. On reaction with hydrazine, there are 2 carbonyl groups. It is very much similar to the previous example, but hydrogen is replaced with the phenyl group. So there is a difference of hydrogen atom and phenyl group only. So reaction is ultimately same. So product is like this: C double bond N, CH double bond N, and 1 phenyl ring is present on this carbon atom. So this is a very much similar example. Now suppose I take then question may be how much products are obtained in this reaction. There are 2 products, both are geometrical isomers of each other. If these groups are different from both sides, then total products are 2. But if these groups are same, suppose in this reaction, so total products are only 1. There is no geometrical isomer in this molecule. So total product is 1. So you can check the total number of oximes, total number of hydrogens by checking the both R groups on the carbonyl carbon. Okay. Now the next reaction is Beckmann rearrangement reaction of oximes. Reagents are H plus or H2SO4 or PCl5 or SOCl2, etc. These all reagents are using to convert OH into good living groups. So these kind of reagents are taken in the Beckmann rearrangement reaction. Now, general reaction is like this. Suppose I take one oxime. This is the oxime with a fixed orientation. In presence of H plus, it is converted into amide. So one oxime converted into one amide. If I take the another isomer of this oxime, then another isomer of amide is obtained in this reaction. Very important part is this: anti group, that is R dash, to the OH group migrate to the nitrogen atom, that is R dash, and the oxygen migrate to the carbon atom. So this amide is obtained. So I write the mechanism. So in Beckmann rearrangement, oximes in presence of H plus, H2SO4, PCl5 or SOCl2 converted into amide. This is an intramolecular rearrangement reaction. So first, mechanism. Suppose I take the same example. This is the orientation. In presence of H plus, OH group converted into good living group, that is OH2 plus. Now in the next step, this group leaves, but simultaneously the opposite group or anti-group migrate to the nitrogen atom to fulfill its octet valential, because nitrogen positive with incomplete octet is less stable. So this step is the RDS step, or we can say migration of R dash, and this migration is intramolecular migration. So carbocation is formed. The water molecules obtained from this reaction again attach to the carbocation, RCOH plus double bond and R dash. Now this H plus removed, and tautomerize. After tautomerization, C double bond O is formed and hydrogen is transferred to the nitrogen atom, and it is a stable compound than this. So one oxime converted into one amide, and important is migration of R is the RDS, and it's a intramolecular migration. That's why first property, configuration of R retains. Second, there is only one product from the one oxime because there is no cross products are obtained. So some important points are like this. First point. Migration step is the RDS. That is right determining step. Second point. Migration is intramolecular. Third point. Cross products not obtained. Fourth very important point. Anti-2OH group migrate at nitrogen. Next point. Number of enzymes taken is equal to number of amides obtained. Next point. In case of cyclic enzymes, always ring expansion takes place. So these are the important points. Now I repeat the complete mechanism. First I take the oxime, that is C double bond and OH group. In presence of acidic medium, OH group converted into OH2 plus. It is a good leaving group. This is the good leaving group. Now it leaves, then R group migrate. This is the slow step that is known as rate determining step, migration of R. This must be opposite to the OH because from the same side electronic repulsions are more. So this R cannot transfer to the nitrogen easily. That's why the opposite alkyl group transfer to the nitrogen atom. Now this carbocation is again gain the water molecule, and after gaining the water molecule, one OH and double bond NR is present. So this group tautomerized and converted into a stable amide. Now question number 1. Suppose first question I take CS3PH this is the given structure. In presence of H plus, the methyl group migrate, OH group remove and methyl group migrate because methyl is the anti group. So product is PHCO NHCS3. Suppose I write the question number 2. So this is oxime in presence of H plus, and suppose this amide is obtained. Then find the structure of oxime. So how do you find the structure of oxime? So what is the answer? So first check the group present on the nitrogen atom. In this case, this is phenyl group. Phenyl group is migrated from the carbon. So it should be at the anti position to OH. So this is the correct structure of oxime. If I take the second isomer, then another oxime, another amide is formed. Hydrolysis of amides is possible in acidic medium. Suppose I take the amide like this, RCO NHR dash. So in presence of dilute acid or dilute base, it's hydrolyzed in this manner. So we get the acid plus amine, and after removal of this water we again get the amide. That is possible on heating. So this is possible on heating. Amine plus acid converted into amide. So now next question is question number 3. Suppose there is a oxime A. In presence of H plus, the product amide is obtained. It is suppose B, and after hydrolysis we get the product like this: PH CH2 NH2 plus acetic acid. Then find the structure of A and B. So what is the structure of A and B? So first imagine the amide after removal of water from the amine and acid. So solution starts from the second step. So after removal of water, I prepare the amide. So PH CH2, or write in this order, CH3 CO NH CH2 PH. This is the structure of B. So according to B, we can find the structure of A. So this group migrate to the nitrogen. So again shifted to carbon, and it should be anti to OH. So this is the answer. Now come to the next question. Question number 4. Suppose I take the cyclic structure. Suppose this is the cyclohexanone. On reaction with NH2OH, it is converted into NOH. This is oxime. So on reaction with H2SO4 or H plus, this is converted into a good living group. It is water. When water removed, this bond migrates. So this bond migrates and ring expand from 6 to 7 atoms. So remove the water molecule and expand the ring. So 7 membered ring like this. I write the numbers, suppose 1, 2, 3, 4, 5, 6 and 7. So this is the 7th carbon, 1, 2, 3, 4, 5 and 6. So bond removed from the second carbon, so positive charge comes on the second carbon atom. Now on adding the water, we get the structure like this, and after tautomerism, finally amide is obtained. This is a 7-membered ring and it is formed by the aminocaproic acid. So it is known as caprolactam. This is a very important example. Now I extend this question. Taking the next question, suppose I take the caprolactam. On hydrolysis in basic medium or in acidic medium. One, two, three, four, 5. This is obtained. This is amino caproic acid. And this amino caproic acid is used to prepare a polymer that is known as nylon 6. So after polymerization, first hydrolysis step is done, then polymerization. We get the polymer NHCH25CO. So OH removed from the acid and hydrogen removed from the amine. So this polymer is obtained, and this is the nylon 6 amide polymer. So this is the extension of caprolactam. So caprolactam on hydrolysis converted into caproic acid, then polymerization it is converted into nylon 6. It is a synthetic polymer. So in cyclic oximes, always ring expansion takes place, either size of ring 6 to 7 or 7 to 8 or 8 to 9, there is no matter. 3 to 4, all expansion are possible in this case because ring expand to increase the stability and complete the octet of nitrogen atom. That's it. Okay. Now I start the next chemical reaction. That is known as Cannizzaro reaction. That is very important reaction for competitive exams as well as for board exams. So next very important reaction is Cannizzaro reaction. First condition. Only those aldehydes in which sp3 alpha CHCD or enolizable H is absent give Cannizzaro reaction in a strong basic medium. This is the condition. Only those aldehydes in which sp3 alpha CHCD or enolizable H is absent give Cannizzaro reaction in a strong basic medium. Reagents are, general reagents are concentrate NaOH, that is approx 50% NaOH, or we can take concentrate KOH solution or K2CO3, aqueous K2CO3, like this. Products are acid salt plus alcohol, means aldehyde oxidized into acid as well as aldehyde oxidized into alcohol. So that's why this reaction is known as redox reaction. So this is redox reaction, and oxidize and reduce both. So this is disproportionation also. Disproportionation reaction. So it is redox and disproportionation also. Now general reaction. Suppose I take aldehyde like PHCHO, in which sp3 alpha H is absent. On reaction with 50% NaOH, on heating, suppose I take two molecules to balance the equation. One molecule oxidized into acid and one molecule reduced into alcohols. So one product is the benzoic acid and one is the benzyl alcohol. So one molecule oxidized and another molecule reduced. So I repeat the total informations first. Reaction is Cannizzaro reaction. Condition: only those aldehydes in which sp3 alpha CH or CD is absent can give Cannizzaro reaction. First aldehydes only, not ketones. Reagents are concentrate base. Products acid, salt plus alcohol. Reaction is redox and disproportionation. Products very simple reaction. Aldehyde convert into acid as well as in alcohol simultaneously. So 1 mole each acid and alcohol are obtained in this reaction. Now mechanism. So I take the mechanism with taking the formaldehyde. Suppose I take the formaldehyde in presence of base. Suppose NaOH is taken. So first OH minus I take to the carbonyl carbon and pi bond is broken. So this intermediate is formed. In the second step, again second molecule of aldehyde is taken. When this negative charge convert into pi bond, so one hydrogen shifted with electron pair to another aldehyde group directly. HCOOH, this is the acid, and CH3O minus, this is the alcohol. So one component is acid, one component is alkoxide. So acid base reaction takes place and H plus exchange between the stronger acid to the strong base. So finally acid salt plus alcohol is obtained. So this is the final product. The step 2 is very difficult and it is known as hydride transfer. So you always know the difficult step or the slowest step is known as RDS step. So this is the mechanism of Cannizzaro reaction. Now rate or kinetics. 2 molecules of aldehydes and 1 molecule of base is taken. That's why order of reaction is 3. 2 plus 1, that is 3. In general, order of reaction for the Cannizzaro reaction is 3. Now, questions. One another thing, hydride transfer from aldehyde to aldehyde. So, hydride transfer from aldehyde to aldehyde only. So, de-exchange at carbon is not obtained in this reaction from the solution. If D2O is taken or NaOD is taken, then de-exchange at the carbon atom is not possible. But oxygen can gain the proton from solution. So O minus can gain the H plus or D plus from the solution. Now write some products. Suppose question number 1. So I take the CD2 double bond O with NaOH. So 2 moles are taken. So 1 mole converted into acid salt, the another mole converted into alcohol. So D from one carbon transferred to the another carbon atom. Question number 2. Suppose I take CHDO. Then H minus transfer easily as compared to D minus. So 1 H transfer from first mole to the second mole. So this is the major product. Question number 3. Suppose I take CH2O in presence of NaOD. Now HCOO minus is the acid salt. Then one hydrogen transferred to the another. But D is obtained from the solution. This is the basic examples. Now come to the another examples. Suppose I take PH, CH double bond, CH, CHO. So this alpha carbon is sp2. So this hydrogen is not used. That's why Cannizzaro reaction is possible. So one molecule convert into acid, one molecule convert into alcohol. So these are the products. Next question may be, suppose CS3C whole thrice CHO, then on reaction with base, one molecule convert into acid plus one molecule convert into alcohol. These are the self or intermolecular Cannizzaro reactions. Now the second is cross Cannizzaro reaction. In the cross Cannizzaro, the small and more reactive, very important. Write like this, more reactive and less crowded aldehyde oxidize into acid and the other one reduced into alcohol. So more reactive oxidized into acid and the other one reduced into alcohol. This is the major product by cross Cannizzaro reaction. So write question number 1. Suppose I take PHCHO with formaldehyde in basic medium. So this is the more reactive, less crowded, so oxidized into acid, and this is the other one, more crowded, less reactive. So PHCH2OH converted into alcohol and this is converted into acid. These are the major product for Cannizzaro reaction. Now similar example, suppose I take CH3CHO with formaldehyde in basic medium. Finally, suppose H plus is added, then again the less reactive is reduced and more reactive is oxidized. In the third example, suppose I take CHO with NO2 and this CHO without NO2, or you can write CH3. Then this is more reactive because of minus M. This is less reactive because of plus H plus I. So more reactive oxidize and less reactive reduced. Because less reactive reacts later on, so first oxidize and second molecule reduce. So these are the cross Cannizzaro type of reaction. Now come to the intramolecular Cannizzaro reaction. Again the same concept is used here, more reactive oxidize and less reactive reduce. Suppose question number 1. Glyoxal is taken. This is suppose glyoxal. OH minus. So first OH minus I take to the any one carbonyl. In this case both carbonyl groups are same. Now when the negative charge converted into pi bond, then hydride shifted to the nearby aldehyde group and the first carbon oxidized and the second carbon reduced after gaining the H. So H plus exchange is converted into glycolate ion. This is glycolate ion, ion of glycolic acid. So I repeat the mechanism. When two CHO groups are present on nearby atoms, then OH attack to the more reactive site. In this case both sites are same. So after reaction O minus is formed, then O minus converted into C double bond O. Then one hydride is transferred from aldehyde to the nearby aldehyde by intramolecular reaction. This is the RDS step, and first atom oxidized and the second atom reduced. So one oxidized into acid, second reduced into alcohols. Now second example, very similar example. Suppose I take the CHO. In this case again intramolecular reaction is possible. So you can write one oxidized and one reduced. But in this case if I add H plus and heat, then acid plus alcohol reacts, then acid plus alcohol reacts and ester is formed. Similar reactions in the next question. Question number 3. In this case Suppose 1 minus M group is attached. Then the more reactive aldehyde oxidized and the less reactive reduced. So final product is like this. This is converted into acid and this is converted into alcohol. So this is the final product. Another reactions, suppose two aldehydes are on adjacent carbon. Then again intramolecular reactions takes place, or one molecule oxidize and one molecule reduce. Next reaction, suppose 4 aldehyde groups are present. This is asked in JE also. OH minus is given. Then two different combinations are possible product. So both aldehydes near to each other exchange the H. So one molecule oxidize after adding the H plus. Second reduce. The same manner, the aldehyde of first ring oxidize, but in the second case, oxidation takes place on first ring with one aldehyde or another ring with one aldehyde. Then total 2 products are obtained. Now some intermolecular reactions. In the question number 6, suppose I have taken this dihaldehyde. Then intramolecular reaction is not possible. So intermolecular products are obtained. So total 3 products are obtained in this reaction. Both oxidize for first ring, then both reduce with the second ring. This is the one combination. And another combination, one oxidize and one reduce. So total 3 products are obtained. The next example, suppose PHCO CHO. This is the intermolecular reaction. In this, it is intramolecular reaction. So first, a take on the aldehyde. Then formation of pi bond. The second one is reduced into alcohol, then H plus exchange converted into PHCHOH, COOH. This is the final product. This is known as mandelic acid salt. So in the today's lecture, we have studied chemical reactions of carbonyl compound. It is the lecture second for this chapter. So I repeat all the chapter. First, addition of ammonia and ammonia derivatives to the carbonyl compounds. This reaction is known as addition-elimination reaction because in the first step addition takes place and in the second step elimination of water takes place. Then the final product is C double bond N compounds. Products may be oximes, hydrazones, 2,4-dinitrophenyl hydrazones, that is yellow orange precipitate, or semi-carbozones like compounds. But in case of amines, primary amines gives imines or shift base, secondary amines gives enamines, and tertiary amines give unstable complex, that is no reaction at least. Now the next reaction was Cannizzaro reaction. So in Cannizzaro reaction, it is a redox reaction, disproportionation reaction, hydride transfer is the RDS. Now in Cannizzaro reaction, those aldehydes can give Cannizzaro in which sp3 alpha CH or CD or ionizable hydrogen is absent, then only Cannizzaro reaction is possible. So in simple Cannizzaro, intermolecular, then cross Cannizzaro between the two different aldehydes, and last the intramolecular Cannizzaro reaction in which the more reactive aldehyde oxidized because of minus M group, it is reactivity is more, and less reactive reduce. In few examples, you have seen the different permutation and combination of products. So here two products are possible, but in this case intramolecular reaction is not possible, but total possible products are 3. In this case intramolecular reaction is possible, that's why only one product is formed. That's it for today's lecture. Thank you.